Hello, everyone. This is Sophia, and welcome back to another video in this series about data visualization in R. So in this next and probably last video in this series, I'm going to be talking about making maps, which is pretty different from what we've done in the past videos, but I think it's useful. You've probably seen visualizations including maps all the time, and it's fun and it's different, so let's get into it. So again, we're using data from the Tidy Tuesday database, and this is about water sources in rural Africa. So, you know, I'm not sure exactly how this data was collected, but I guess some surveyors went and like cataloged where in rural Africa they found water and sources like, so this isn't really running water of the type you find in cities. It's like wells or like regulated streams that have drinkable water, things like that. Yeah, so here you can see some of the variables that we're going to be looking at. Really, since we're going to be making a map, really the most important ones here are latitude and longitude. And maybe things like country. Yeah, so again, I'm going to be operating from my kind of pre-written code, but I'll be explaining things as we go along. So let's load this data in. And this is actually a very large database, as you can see. So it's 55 megabytes on its own. But yeah, you can kind of see some of the types of data we have. We have from different countries, like water sources like boreholes, and that's just a narrow, long kind of drilled hole where people get oil or water out of, springs, shallow wells, things like that. Okay, before we get into like actually working with the data, first of all, you want to use this package called ggmap. So let's open that library. And you immediately see something new pops up kind of. It says like Google Terms of Service. So this is actually like, we're going to be using like Google Maps for our first map that we're going to be making. So that's why Google's saying here, like, please cite us if you use us. And actually, this one's a little more involved. This like library it's not as simple as just like opening up and using it. I thought it was that simple. I started trying to use it, and I got all these like weird notifications from Google saying like, oh, you need like an API to use this, and I was like, what is an API? But really, apparently this wasn't always a thing, but now to use Google services in R, you need to like use your account and sort of enable some like APIs, get an API key. It sounds really complicated, and it is if you're working from scratch. But I did find eventually this like really nice sort of tutorial for how to get things running. So this is probably the hardest part of this whole thing. Like if you can get the API working, you should be good to go for everything else. But I promise it's not that hard. But you can use this little command, register Google, to give you some information, and you can use this website, and hopefully that'll get stuff running. I don't want to spend too much time on that. But yeah, let's open up this library. Let's subset this data. I'm thinking when I went through this data, I looked at Algeria and water sources in Algeria, but actually, now that I think about it, there weren't that many in Algeria. So, but you know what? Let's use it anyway. Let's quality over quantity. Yeah, so we see there's just 14 water sources. Okay, obviously there's more than 14 water sources in Algeria, but out of the ones that are like cataloged in this database, there are 14. And let's make a map. So right now we just have latitude, longitudes. We can't really like tell where they are in relation to each other, but seeing it on a map gives us some information that we wouldn't have otherwise. So, I've written down some steps in general for when you want to visualize something using this like GG Maps package. So the first thing you want to do is find the center coordinates for your target area. So if you're looking at a city, find the center coordinates for that city, and then you'll have something to like work off of so the equivalent for what we did before for like filtering, mutating different variables, the equivalent here is like narrowing down on the exact like frame that we want. So when you're in Google Maps and you're like scrolling around with your finger or like zooming in and out with your fingers, we're going to be doing that, but with just like values of latitudes and longitudes. And to get a starting idea, we just find the center of whatever we want and we work from there. So actually Google has this nice function called geocode, and you can type in pretty much every place. I just typed in like the name of Algeria and it gave me like the coordinates for the center of Algeria. So let's run this, and it'll get us this longitude, latitude that we can start working off of. So our second step would be to get the background map image, and you'll see what that looks like in a sec. Basically, we're just, without plotting our data from this water source, right now we're just constructing like a basic map that we can start graphing things on. And so for this, we can use this get map method, where we put in the center and then we give it like a zoom. And what the zoom does is like, if the zoom is equal to 1, that's just gonna be the whole Earth. Obviously not very useful. Well, it can be useful, but for our purposes right now, not very useful. And the larger you get, I think you can get up to 21, you're going to be kind of zooming in. And I think 21 is basically just like you're zoomed into like a building. So I've messed around a little bit. I think 5 is good for the size that Algeria is. It's a pretty big country, but not like huge. 5 is a good size for that. And you'll see in a second. There, we've made our map. And now we can, and also the map type. So you can do the same things you could do in regular Google Maps. You can have like a satellite view, like a hybrid view. There's all sorts of different things you can do. But for right now, this is just gonna let us view this map. Oh, there it is. So yeah, you can see we have Algeria, right? So in the center, I guess we can confirm that the center that we found is correct, because this center of Algeria seems to be about at the center of this frame, and that our zoom is about right. And, if we zoom in a little more, we're going to cut out parts of Algeria. So we should just leave it as it is. Yeah, so now we have a nice background image, and we can start like plotting points on. And I say points as if this is a graph, because it kind of is, where the longitude is the x-axis, the latitude is the y-axis, and we can start, plotting some of these using this latitude degrees, longitude degrees. We can start putting some points here where we have water sources. And actually this type of graph is called a dot density map, because most of it is just dots. You're not worrying too much about like shaded areas like you might be in some other maps. Here you're just putting dots on the map at areas of interest, in our case, water sources. So yeah, let's add these water locations. The way we do that, we use this GG map function, which sounds kind of similar to GG plot, just saying we're having like a theme throughout, but we're going to use GG map. We're going to have our map here, and then we're going to make, we're actually going to include a GG plot within this function, where we have our data, this data here, and we're going to tell it, the same way we mapped X and Y axes in like a scatter plot or a line plot. We're going to do the same thing here, just assigning the x-axis to the longitude, the y-axis to the latitude. And here we're just specifying, again, this geometric point object. We're going to have some blue points, blue for water. Yeah. And so, yeah, now you can kind of see, again, like I mentioned, this data set doesn't include too many points. There are 14, and they seem to be pretty clustered together. But what this gives us room to do is kind of zoom in, practice zooming in on this like area of interest. So at this point, we might not be interested in all of Algeria. We're like, okay, I want to see what's going on here. Because right now it just seems like, you know, can kind of see like a few points, but you can't really see the details. So let's try to like manually zoom in there. And I guess the way you could do that is to pick out a new center and make like a new smaller map. So for me, you know, the center, if we wanted to center it around these points, we might go to longitude of like -7-ish or -8 and a latitude of like 27, 28. That I think would be a good choice. And so I went with -7, 27. And so we're just going to change these longitude and latitude of the center to fit, and we can confirm, yep, we've changed them. Now we can make a new map. And this time I'm going to do zoom 8. I'm going to zoom in a little more. So before we did zoom 5, and now I'm going to knock it up a notch so we can really focus in on this area right here. Okay, we did that, and now we need to view it. Okay, so now we focused in on this little area. Actually, you know what, let's mess around a little bit with the zoom. Let's see what happens if we hit like zoom 7. That should be zoomed out more. Reached, elapsed. Oh, okay, there we go. Now we can see Algeria's a pretty big country. But right now we're just looking at this little tail where our points were. Or we can try going to 9, a little more zoomed in than we were before. Yeah, so now we're just focused on this like really small area where it doesn't seem like there's going to be a lot going on. But it's hard to tell because we know we've made a new map, so we don't have our points there yet. But let's set this back to 8. And then we can plot our points the same way we did before, just on a new map. Except let's wait for this original map to show up. There we go. Let's plot the points again. So yeah, now they all fit really nicely, I think. I think if we zoomed in more, we'd be leaving out some of them. And if we zoomed out, it would be unnecessarily large. But, you know, we can see a bit more detail maybe. We can start to see there's a lot right around the city of Tindouf. There's a lot of, what type of water? Yeah, a lot of boreholes, a lot of these mechanized pumps right around the city here. Looks like there's 1 here, maybe 2, and a few here, because as you can see, we've set the points to alpha equals 0.4. Now, if you remember, alpha is like a measure of transparency. So we've set these to be semi-transparent, which is nice because it seems like there's some really close together where it's hard to focus in. But you can kind of see the darker it is, the more there are in the area. But, you know, we can mess around with this a bit more. Like, I think might help if we make the size of these points a little smaller. Maybe that would help us see a bit more clearly. So if we set size to 2, yeah, they start spreading out a bit, maybe even to 1. Yeah, and then you can kind of see like a little trail of points. And actually, you know, since there are a bunch here, let's try to zoom in a bit more. I haven't actually tried that before, but you know, it's improv. So it looks like the center might be around -8 now, if we want to really just zoom in next to this city. In the latitude, center might be like 27.7, I'm gonna say. So we set that, and now zoom at the center. Let's make the zoom bigger, maybe 10. Let's try that. Okay, so now we've really like zoomed in between the city and this like body of water. Let's see what comes up if we graph our points now. Okay, so now we can really like see individual points, which is, they're still pretty close together. But yeah, you can really see like this, you know, these points, these different wells. So I guess PSA, if you're ever in the Algerian desert, like stranded, head to Tindouf. There's lots of wells. Yeah. And so that was pretty much all I wanted to show for this type of map. Dot density maps, these can be generalized to like any type of points. As long as you have a longitude and a latitude, you can sort of plot, I say in parentheses, plot these points on this map. And you can, again, using this like cool Google Earth feature, Google Maps feature, you can zoom in on whatever place you want. And it'll be just like if you were on your phone and zooming in with your fingers somewhere. But as I mentioned, you're basically like, I don't know why they're so protective of it, but it seems like you're basically like a developer. Like I was filling out some of those forms and I felt like, yo, am I working for Google now? Like they kind of ask for a lot of information, but you get to use these cool like Google Map feature. And now I'm just gonna make this like look a little nicer. It already like, you know, we have the Google feature. Doesn't look too shabby, but let's run this code. Yeah. Yeah, so now, you know, I've kind of gotten rid of the latitude, longitude lines. Those probably aren't that useful if you're just trying to find some water. You know, you might want to look more at the points. So I just got rid of that, added the source, and put a title here: location of boreholes near Tindouf, Algeria. Yeah, and so that's pretty much it. That's what I wanted to look at with this type of map. And the next type of map I wanted to look at was a Choropleth map. I don't know how that's pronounced. I'm going to say Choropleth, which is kind of, these are probably the ones you're obviously familiar with these if you've ever used any sort of navigation service, anything. But these shaded maps are used a lot in like visualizations, map visualizations. And these are the types where, you know, you have like a picture of like, you know, during the US presidential elections, you'll have a map of the US and you'll have your states shaded different colors, like darker blue, maybe like more red, like purple for swing states. That's an example of a shaded map, which is kind of what we're going to be doing. And those aren't really called Choropleth. This is more of like just a package that we're going to use to make these maps. That's not really what they're called. And yeah, let's say we want to count the number of water sources in each country, and then we want to make like one of those shaded graphs where, let's say, if we had more water sources, the graph was like more blue, and if we had less, it was like less blue. And each country is shaded according to like how many water sources, not necessarily that it has, but that it has in this like survey, which may or may not be representative of like real life. So I guess let's run these. Actually, this is going to cause problems. I'm going to exit from this really quick because for some reason these two packages, plur and diplur, tend to conflict. And so it wants me to load one of them before the other. So let's do that. Let's load this one first, and then this one. Was it supposed to be the other way around? You know what? It's fine. It'll be fine. It worked for me last time. So one command that is found in this, I think, plur package is count, which is exactly what we want to do. We want to count the number of like times that a certain country shows up in this list. So we don't really care about the individual latitudes, longitudes. We just care like about this label here. So we would, for example, in Algeria, we had 14. So Algeria will show up 14 times in this column, and we want to count those times. And we use this command to do that. And here we already printed out like a nice table for me. See, Algeria 14. And, you know, some of them have like a lot of data, like Ghana has like 21,000. Yeah. And we can make this into its own table. So now it's just printed out this data. We can set that equal to like this df table. data frame, I think it stands for, usually an R. That's why I used it. And now there's like this random, I don't know what NA is, it has 10, wherever NA is, it has like 10 water sources, but let's just get rid of that because I don't know how it's going to be graphed. So yeah, now the way I did that was I filtered, if you notice, that's the only one that has 10, it shows up 10 times, and there's probably a more nuanced way of doing it. I just said keep everything that doesn't have 10 frequency. So that's one way to get rid of it. Now we have some requirements that we need to satisfy before we can actually use this like Choropleth package, because it's not as flexible as the ggplot commands that we've been using. It's like we need to set the country variables must always be equal to region, or any type of map that you're making in this package, whatever like your regions are, whether they're cities, states, countries, they just need to be called region. Whatever your like frequency variable is, it needs to be called value. So just region value, and then the region value, that's kind of confusing. Region value is more like region names must be all in lowercase, and we can see here that right now our country names are capitalized as they grammatically should be, but for this code to run correctly, we need them to be in lowercase, and we need them to be named like the correct country name. So basically somewhere in R is stored like this like data frame that has the names of the countries, which allows us to like put them onto a map. But for example, we have a nice list of the countries here. This particular data set used like Congo, Kinshasa to refer to the Democratic Republic of Congo, because Kinshasa is the capital of the Democratic Republic of Congo, but the actual code won't recognize this as a country. It only will recognize this. So we need to assign them to the correct label. And I think most of them are labeled just fine. It's just the name of the country, but a few need to be relabeled for it to work correctly. And, you can just pull up a reference list for those, but I have the African ones right here, where the two Congos need to be respectively relabeled, and Tanzania needs to be called the United Republic of Tanzania. So just minor things, but you need this for the code to work correctly. And if we go further up, again, if you remember, this just is a nice way to put this all into one sort of thing of code where we're sort of going through and assigning whatever we get in the previous step to the next step. So here we're going to rename the country names. We're just going to give it the name region, like we're specified here. And for frequency, we're just going to rename it to value, like the second bullet says. And then this method toLower is just going to put everything in lowercase, and then this recode is going to give everything, not everything a new name, but the things we want a new name, it's going to give them a new name. So through this code, we've satisfied these 4 requirements. We can run it now, and yeah, so now we have our plot data ready. Plot data is what we want to plot. And now we have everything set up correctly. We have region value, we have everything in lowercase with the correct names, and we have our frequencies that we want here. Now we're going to actually run this like package Choropleth, and then we're going to run this simple sort of method country Choropleth, when country is going to indicate that we just want a map of the world where we're looking at all the countries. That's what we're going to do for now. And there we go. It doesn't look that great because a lot of our countries are in black because there was no data for them because they're not in Africa, except Peru. Peru is included for some reason with some of these African countries. But the rest of the black countries are just marked NA because they weren't given like a value of frequency. Oops, that's not, I need to zoom in on this. But yeah, we can see some sort of interesting stuff that we can examine. through this, and we can see that R kind of automatically gave them a range of values for each color, and they're not equal, right? Because we mentioned that some countries have like an insane amount of data, like Ghana, right? Yeah. And some have much less, like Algeria has with its like 14, or Egypt here doesn't look like it has a lot of data. Yeah, and this lets us kind of scale our perception so that it's not just, you know, everything is, how do I say this? So we don't need like a bunch of colors to represent all of them, or if we just have a few colors, everything would kind of be the same color, you know, if that makes sense. So let's zoom in kind of and look around here. So we have Algeria, it's light blue shade. We have some of these countries in a darker shade. Yeah, so it seems to be like is kind of what we wanted. And, you know, I didn't really specify a color scheme, but like it was reading my mind, art gave it on like a blue scale where the darker blue is more water sources. And again, these aren't necessarily representative of the country, they're just representative of the data that we have. And we have Peru over here. But you might be wondering, like, why couldn't we just like zoom in and just have it plot Africa as a continent with countries within it? Why did we have to do the whole world? And the answer to that is there's probably a way to just have Africa represented, but I couldn't find it. I looked around on the internet, I was like, okay, using this Choropleth package, is there a way to just have Africa isolated from the rest of the world? And I couldn't find one. I did find one for like the United States, like the contiguous United States, a way to just isolate that and have, you know, the different states color different things, but I did not find one for the continent of Africa, which is a little disappointing. But, you know, there's always the zoom feature. If we want to look closer, we can zoom in and have a look. So yeah, I think I'm gonna end this video here. I don't, you know, all the stuff that we did here can be pretty easily modified for if we want to look at all the countries in the world. You just have to remember there's some when you're using maps, as I found, there's some pretty specific rules that you have to follow that might not apply in like the data we were analyzing in the past. Like, you know, even from the whole process you have to go through just to get this package, like registering with Google and getting an API, it's a bit more involved. And here when we're constructing this Choropleth, renaming all these variables, it's kind of back to that kind of slow work of processing, cleaning your data that you have to do. But, you know, it's worth it. We have a really cool, I think, representation of the data here that I don't think it would be as interesting if it was just like a, you know, thinking back to the last video, we could have made like a bar chart comparison of a few countries and like their number of water sources, or like we could have compared like Northern Africa to like Western Africa, and have like a summary statistic. But I think here it's like, you know, you get a lot of information without needing to like squint a lot at the numbers. You just see, oh, like this country's darker blue, so it has more water from the table than does like a white country. So yeah, you know, pictures do speak louder than words. That's the saying, right? Or 1,000 pictures worth a no, yeah, pictures worth 1,000 words. That's what I was looking for. Sometimes it's a lot easier to just glance at a map than it is to look at a bunch of like dots on a table. Yeah, so with that, I'm gonna wrap up this video. Thank you for watching. Again, I really appreciate it. And maybe there'll be more videos in the future. Who knows? Bye.